Let's do another example. This is one of my very favorite examples. What are the expected return, expected variance, and expected standard deviation for a stock? Currently it's priced at $20. We know that the outcomes are bad, medium, and good. And we're told where the stock will be in a year. If things turn out bad, it'll be at 10, no dividend, and there's a 20% chance of that happening. Medium, the price won't change, it'll still be at 20, but there'll be a dividend of $2, and there's a 30% chance of that happening. And there's a 50% chance that things will turn out good, in which case the stock price will be priced at 30 and you'll have a $3 dividend. Well, remember, we need three things in order to figure out the expected return, expected variance, and expected standard deviation. One is what could happen. We have that. Another is the probability of those happening. But the third thing we need is what is the returns for each of the outcomes. And we don't have that, but we have the information where we can figure that out. If you remember, the return over a particular period is equal to the cash flow, which for a stock is the dividends, and we can see what they would be if things turn out bad, medium, or good. Capital gain, which is the ending price minus the initial price. We know that the price initially today is 20, and we're given what the price will be in a year, which is the ending price, and divide by the initial price, which is the price today, which is $20. So we can figure out the return in each outcome. If things turn out bad, we get no dividend. Our stock price would be valued at 10, and today it's at 20, so that's a $10 loss. So what would our return be if things turn out bad? Negative 50%. If things turn out medium, we get a $2 dividend. Stock price doesn't change, so our total dollar return would be $2, so it's a 10% return, 10 over $20 if things turn out medium. And how about if things are good? If things turn out good, we wind up with $3 in our pocket from the dividend, plus the stock price is expected to increase from 20 to 30, which is an additional 10, which puts 13 as our total dollar return divided by 20 is 65%. So now we have all three components: the return in each state, the likelihood of each state, and then what each of those states is. So now we can move forward. So we know the three outcomes. We know the likelihood of the three outcomes. We know the likelihood of the three outcomes. We know what the return is for each of those three outcomes. Let's find the weighted average to figure out the expected return. Expected return is 25.5%. 20% chance, 0.2 times negative 0.5, because if things turn out bad, there's a return of negative 50%, plus 0.3, 30% chance if things turn out medium with a 10% return, plus a 50% chance of this very high 65% return. You add it up, and across all states, we expect the return to be 25.5%. Next step, find the deviation. If things are bad, also I'll mark this in as 25.5. If things turn out bad, you're way down here at negative 0.5. So let's make this guy 0. And so you're under the expected return by 75.5 percentage points. The deviation is negative 0.5 minus 0.255. If things are medium, you're still here, so you're still under, but by 15.5 percentage points. And if things are good, you're way out here, you're over 0.65 minus 0.255 by 39.5 percentage points, 0.395. Square those. Take each to the power of 2, and again notice the two that are negative because the return in the state is less than the expected return. When you square them, they get positive. What's our weight? Our weight is equal just to the likelihood of the bad, medium, and good. And so let's take a weighted average of our squared deviations. 20% chance of this squared deviation plus a 30% chance of that squared deviation plus a 50% chance of that squared deviation is going to give us our variance in a second. But here we have each of the three terms, the products, add them up. And the variance for this stock is 0.199230. Take the square root and the standard deviation is 44.6%. So when you just look at the possible outcomes, you can say, wow, that looks volatile. The good one is just as likely as either the bad or the medium. Together they're 50% and that guy's 50%. And we do all the work and we come up with one number, 44.6%, that captures the unpredictability as far as the actual return that's going to show that's going to wind up taking place and how it compares to the expected return across all different possible outcomes. If you want to use the formulas, find the expected return, the probability of each of the three outcomes times the return in each of those outcomes, you get 25.5%. So there's a 20% chance that things will turn out bad, in which case that's your deviation and you square it. 30% chance of things turn out medium, and there's your deviation, square it. 50% chance that things turn out good, in which case you're at 65%, which is well above 25.5%. Square it, add it up, and you get 19.9% roughly. I'm sorry, that's the variance. The variance is 0.199225. It's actually in percent squared, so it's good to stay away from the percent terminology until you take the square root and get the standard deviation, which is 44.6%. And so again, this is just what we just did in the table, but the table helps break up each element into a separate component.